Okay, I really like Lewis structures because they are such a quick way at getting a visual of the chemical behavior of any given atom. Well, of most given atoms. I like how very quickly you can determine, oh my God, this thing wants to gain electrons. This thing will form four bonds. This thing will form three bonds, but it won't be tetrahedral because there's that lone pair there. And all those things tend to agree very quickly with reality, at least for some of the simpler atoms. I'm also aware that when we try to use more complex analysis, like electron configuration using the Aufbau order with orbital notation, you're getting into trouble when the words get long and complex like that. It can fail for even simple things. Take a look at the electron configuration of carbon before we hybridize it to try to repair it, if you will, to fix any shortcomings it has. Okay, so you get my point. Lewis structures can be pretty awesome. I should point out that they don't have any right in here, and the reason is because a Lewis structure is an analysis of the valence electrons to get a good feeling for what's going on. After all, usually everything's filled inside, but not so with these ones. For most of these, you have an unfilled inner shell, and therefore it's going to mess things up. You can't just look at the outer shell if the inner shell is also unfilled. And so we don't consider these for Lewis structures. But for all the other ones, it's just a matter of valence electrons, right? One, two, three, four, five, six, seven, eight, and just arrange them in pairs around a square, and you'll very quickly see that if 8 is the gold standard, this wants to gain 1, these ones want to lose 2, because there will be 8 underneath. These ones will want to lose 1. These will want to lose 3. There's 8 underneath. The ones with 5 will gain 3, 6 gain 2, 7 gain 1, 8 are all set. Boom, nice and quick. And we can use it to show molecules. So when hydrogen combines with oxygen and another hydrogen atom, squeeze them all together and we can show water forming. Notice that the dots, the intersecting areas, the two dots are the chemical bond. We can replace it with a line. For carbon dioxide, we can show by a similar analysis that the double bonds will form. I mean, carbon does form four bonds. It's the only way you're going to do it. And by the way, it is linear like that. And these circles are great for showing, yeah, you got 8 electrons there, you got 8 electrons there, and by sharing 4 electrons, carbon has 8 electrons there, giving us the two double bonds. Triple bonds can occur as well. Nitrogen's the common one. So it had those 3, where is it? It's 3 bonding electrons. If you can think three-dimensionally, take another one of these, put it right on top of it, and have it come down, and you'll get the bond there, there, and there. If you need to see it linearly, they kind of violate Hund's rule, if you know what I mean, just to line things up in a linear fashion. Molecules are not just on paper like this. They have 3 dimensions. But this works, and you can see that you have your 8 electrons, and your triple bond. This is a quick look at Lewis structures.